Okay, so probability part is done, and so this is another little thing that's kind of just added on, and it really has to do with statistics. So, but it's probability is what happens in the long run. How come a casino can give away a $500,000 prize? Well, in the long run, they've made much more than $500,000. So it's always about the long run. So that's the thing. What happens after an extended amount of time? It's called the expected value. Okay, and the easiest way to do this is to multiply each outcome by its probability and then add them all up. Multiply, add them all up. So we're going to do a very, very simple thing, okay? And you make this little table. Here's what could happen. We got a pointer that lands on one of three regions, and let's say it's they say it's equally probable. So it can land on a 1, a 4, and a 10, or a 10. And there's a 1/3 chance it's going to land on one of those. So the probability of X is that. So to do expected value, you make a are we okay with that? Here's what could happen. Here's the probability of those things happening. Sometimes these are not the same number, okay? These aren't going to be all the same number. All right. So we're on page 26 of chapter 11. So you add a column and you write X times the probability of X. So what's 1 times 1/3? 1/3. What's 4 times 1/3? 4/3. And what's 10 times 1/3? 10/3. Okay? And then you add these all up. Add this row up. So 10 plus 4 plus 1 is 15/3, which is equal to 5. So here's the weird part about expected value. If you have this spinner and you're spinning it, okay, what do you expect to get? Not during class. Oh my, sorry. Not during class. All right. Here's what we do. What do you expect to spin? You expect 5. Will you ever get a 5? No. But if you did it over and 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 over again, spin, you would average a 5, or really close to a 5. Okay? So I always think this way. You seldom get what you expect.
What did you say?
You seldom get what you expect. Seldom. Not very often.
You've never heard that word?
No. Seldom. Okay. Who's your English teachers? They're crying. Okay.
Get what
You expect. Do you always get what you expect in life? Do you get what you expect for Christmas or birthdays?
Yeah.
Do you? That's nice. Because you tell them what they want.
Because they ask me if they don't know.
Because they don't know who I am. Okay. All right. Anyway, this expected value often comes out as a decimal. Okay. Don't freak out. Okay. Don't freak out. So let's do one more example. A fair 6-sided die. First thing is, what could happen? I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay? What's the probability of each one of those things happening? 1/6. multiply each by its probability, each item by its probability. And we get 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. 6/6. Add them up. 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21/6, which is 3.5. Will you ever roll a 3.5?
Yes.
You will never roll a 3.5. Okay,
Yeah,
however,
like lands like sideways on like the
the,
middle between
the 3 and the 4, are the 3 and 4 touching on a die?
No.
No, they're not. They're on opposite sides. Okay, did you know that opposite sides of a die add to 7? Did you know that?
No.
Yeah, it's fun stuff about dice. Okay, so there's the expected value of rolling one die is 3.5. All right, I think it's kind of fun to think about this stuff. All right, so insurance companies use this, and so but they use empirical probabilities because they really don't know how many people are going to have a claim or file a claim. So they use this for their long run stuff. So here's their chart of what's happened in the past. $0 were claimed by 65% of the people. 65% of the people don't have a claim. I have insurance, but I had no damage to my house ever the whole year, so I'm part of this part. Okay, now 20% had a claim that was around $3,000 or average $3,000. 10% of the people, their claims average $6,000, and 5% of the people, their claims average $9,000. So what's the expected amount that people will claim on their insurance? So it's the same thing. They've done the first two columns for us. We do the third column. 0, and you can just do it in your calculator. You don't even have to write it down. So 0 times 0.65. Why did I just do that? Right. Okay, so you don't even have to do it, right? So you would love zeros. Okay, so we won't do that. Well, we did it, but we don't have to do it. 3,000 times 0.2 plus 6,000. Oops, went too far. Times 0.1 plus 9,000 times 0.05. Boom. So 1,650. So the expected value, and use a capital E, is 1,650. I don't know if you'll see that capital E or not in this class. You will in the next class. Okay, 1,650. So how much should the company charge so they don't lose money?
1650.
Yeah. More than $1,650, or at least $1,650, at least. Will they charge $1,650? No. They want to make some money, right? So they can charge whatever they want to charge, how much money they want to make. So here's my story about this. When I moved to this town, I called up the State Farm. I said, I need homeowners insurance. And they said, oh, we can't issue any more policies. And I said, really? She said, yeah. And it's because if one insurance company, here's your town. If one insurance company insures all these houses right here, like they're clumped together, and a tornado comes through and goes right through there, then they'll have too many claims. So an insurance company wants their stuff really spread out. So right. So hurricanes are tough for insurance companies. So that wipes out a big swath. Tornadoes are not so bad because there's not very, unless there's a 1 mile wide tornado, which what happens sometimes. But anyway, that's kind of interesting as well about the insurance agencies. Okay, so here's another exact same example. Can you all do that? I mean, you just do this with the calculator, right? Do we need to do this one? Same exact problem. Multiply, multiply. Just the numbers are different. Okay. Let's not do this one. This you'll have this will be in your homework. Did you do any homework in the last 24 hours?
I did not.
Oh, dang it. All right. So here's the better stuff. All right. We're gonna open a casino because we'd like to make some money. Okay. So we're gonna make a game. And what you do is you multiply either that you would gain money or you would lose money, right? And you would multiply it by the probability and then add it all up, and you're going to find this expected value of this game. So here's the first game that we're going to look at. And one is that you bet $1. It's roulette board, okay? A roulette. All right. And you bet $1. If the ball lands on a red number, you get $1. And you keep the one that you had. So I bet $1, but then I won $1. Okay.
So you have $2?
So now I have $2, right?
You have $1 because you got rid of that $1.
Well, it's returned to you.
Technically
You're up 1.
earned.
Okay, so this is the whole thing is they're going to say, hey, I won $2. But did they win $2? They won $1. So this is kind of fun when people say, oh, I just won $20 on a lottery, on the scratch off. Yeah, but you paid $5 for the card. So you really only won up 15, and they get really mad about that. Then I go, really, you ought to say all the times that you lost and add those up too. Okay, so if the ball lands on a black or a green spot, you lose your $1. Okay, so so the outcome is it can land on red, it can land on green, or it can land on black.
I gotta get my different weapons out here.
Yes, it'd be nice at this point to figure this out. I don't know how many things are on roulette wheel. Okay, so if it lands on red, I'm up $1, right? Plus $1. If it lands on green, I lose my $1, and if it lands on black, I lose my $1. Okay. Got it. Okay. So how many spaces are there on a roulette wheel? And so they're numbered 1 through 36, and then I think there's 2 black ones. No, wait a second. Is it red or black? Wait a sec. Wait. Okay, there's 2 green spaces. Okay. Hello. Yeah. No. Maybe.
This lid was swallowed.
Yes. Yes, you said to fill out the form.
Get that thing.
What do you mean?
But like,
Oh, whatever you want to. No. Okay. Okay. All right. Bye. Okay. All right. So there's 18 black ones, 18 green ones, and
is that there was 2?
red. Don't talk on the phone and try to do this. Okay. 18 black, 18 red, 2 green. I don't know enough about gambling. All right. So that's a total of 38 spaces. Okay. So
Why are they numbered like the basics?
these 8 and these are numbered 0 and 0 0. The 2 green ones are 0 and 0 0. And there's all kinds of different ways to bet on a roulette wheel. Okay, you can do primes, you can do odds, you can do evens, you can do blacks, you can do reds, you can actually pick a number, you can pick the green one, all kinds of, there's many ways to bet. All right, so what's the probability of me winning Again, in the red, it'd be 18 out of 38. Of green was 2 out of 38, and 18 out of 38 to do that. So now we need our
People actually bet on green.
yes, because you get paid a lot more,
Yeah, but there's
a whole lot more. Like you get paid 30 bucks or something for every dollar that you, if it lands there. Yeah.
2 out of 38.
Oh, so you probably get 20 bucks or 15 bucks. Yeah. You're gonna lose. Over the long run, you lose. Okay, so then you multiply this times this, and so this becomes 18/38. This becomes negative 2/38. This becomes negative 18/38. I'm just multiplying, right? This is, oh sorry, x times p of x. And the chart's too small. You add all those up, and you get negative 2 over 38. What the heck is negative 2 over 38? To a decimal. Nope. Oh yeah, it's 2 and then 1 and then enter. Seems like a lot of work. All right, so it looks like it's negative 0.0526. So basically, that's my expected value. That every time I play a dollar, I would assume that I'm going to lose 5 cents. I never lose 5 cents on one time, but over the long run, I will lose 5 cents every time I play. So if I play 100 times, I'll lose $5. So you can sit there for a long time, except they don't let you bet just $1. I'm pretty sure it's probably minimum 5. Okay, so here we go. Last 2 questions. Okay. All right, so you're having a raffle. You sell 1,000 tickets for $2 each. Great way to raise money. So you get $2,000. One of the tickets will be selected to win the grand prize of $1,000.
You're only getting $1,000.
2 other tickets win $50 each. So you're going to win $900. You're going to raise $900. This is a great way to raise $900. Right? Because everybody's going to say, oh yeah, I'll buy a ticket. I don't care. And somebody's going to win $1,000. You put that on Facebook. Hey, we're our winner of $1,000. Fantastic. And if they're generous, they'll give it back to you. Because it's a fundraiser. This is split the pot, basically, what this is. Okay? So, actually split the pot is less. You can make more money on split the pot. Okay? Because the split the pot people, oftentimes, the winner often just donates it back. Or half of it back or something.
What is split the pot?
Project graduation. Okay. So, if I buy 1 ticket, so I could win, right? I could win $1,000, right? Or I could win the $50, or I could lose. Those are the 3 things that could happen, right? Okay. Do I win $1,000?
Wait, what was the thing you put under the win-win?
Lose.
This is a lose.
Loose. Loose? Okay. Alright, so do I win $1,000? No. I win what? I bought the ticket for $2. So I gave them $2, they gave me $1,000, so I only won $998. If I win the 50, I didn't win $50, I actually only won $48. And if I lost -2. So those are the things that could happen. Now, what's the probability of those things happening? How many winning tickets are there? There's one grand prize out of how many? 1,000? Okay. And there's 2 out of 1,000 baby winners. And there's 997 out of 1,000 losers. So then we go x times probability of x. So I just multiply, and I get 998 divided by 1,000. I multiply, I get 96 over 1,000. And I multiply, and whatever that is, negative 1,994 over 1,000. Is that right? 14? 96. Isn't it 2 times 48? I think so. 48 times 2 is 482. 96. Alright, so now I'm going to add these up. And I get 998 plus 96 minus 1994. And I get negative 900 over 1,000. And that is equal to a negative 90 cents. So every time I spend $2, I'm only really spending 90 cents. It's weird. If I bought every single ticket, I would have lost $900. The fundraising thing is going to raise $900. Make sense? A little bit. Okay? So that's what that means in practical terms. If I purchase 5 tickets, so it'd be 5 times a negative 0.90, which is a negative $4.50. That's my expected. Mm-hmm. Hands are cold. We're almost done. We're almost done. We're stay with us. Get some sleep at night. Okay, here we go. So this is a game that you play with 1 die. So we know there's only 6 chances here. If the die is rolled and shows a 1, you earn $5. So here's what could happen. I could roll 1, 2, 3, 4, 5, or 6. If I roll a 1, I'm up $5. If I roll any other one, I win 0. There's a charge of $1 to play. So if I roll a 1, I'm up $4, correct? And if I roll anything else, I lose $1. And the probability of all those things happening is 1/6. You multiply the probability times the outcome. We get 4/6, negative 1/6, negative 1/6, negative 1/6, negative 1/6, negative 1/6. Add those up, which comes out to negative 1/6, which is negative 0.17 cents. So you'll lose $0.06 every time you play this game. However, you'll never lose that exactly on one, but on the long run, over time. So when casinos set up their games, they calculate this to make sure that they're making money in the long run. And they're making sure that they're paying for their people that are doing security and the air conditioning and the rent and the mortgage and whatever else, the taxes they have to pay. They're doing all that in and still coming out to make sure that they're making money every time somebody rolls. Do they lose the money sometimes? Sure they do. And when they do, they make a big deal of it to get other suckers to go up to the casino and give them money. If you would like to give them your money away, I will take it as well. You can give it to me. All right, that's it. That's the end of chapter 11. Do your homeworks. I believe everything has been fixed for due dates. There was one I found that I forgot to put a due date on. Simple interest one. Never put a due date on it. So that one's not late. And I put these all till Tuesday after Thanksgiving. Okay? So there's only four for this unit. So get them done. We're going to finish chapter 12 Monday, and then we'll start reviewing next week. Monday, Wednesday, Friday. Friday we will not meet. So Monday, just Wednesday, I guess. Well, we'll see. See how college algebra is doing as well. And then we'll go from there. I think I kind of want to review after Thanksgiving.